Welcome to Spaceverse, your portal to cosmic adventures. Who is to blame when we discover structures in space that do not appear to fit any theoretical description? Is it the cosmos or our theories that are to fault? Over the course of the previous 2 years, the James Webb Telescope has been using its infrared perception to investigate the structures that are the oldest and most distant in the cosmos. It has been proved time and time again that the outgrowths of the real cosmos are not interested in our ideas, and the existence of these outgrowths throws accepted cosmology into turmoil. For example, no one has yet figured out how galaxies the size of our Milky Way could have existed even a short time after the Big Bang. This is a concept that has not been fully understood. But this is by no means the only enigma that Webb has added to the star maps. In fact, it is not even close to being the only one. The astonishing flowers that the planetary system of the universe is capable of creating have also been brought to light by this discovery. In the same way that day and night cannot exist without the other, ebb and flow and the planets that orbit their nearest stars are inextricably linked. This should not come as a surprise in any way, shape, or form, because every planet in our solar system revolves around the Sun. Additionally, when we extend our view beyond the galactic horizon, we notice that the one distinguishing feature of an exoplanet is that it orbits a star other than our own Sun. This is the only trait that defines an exoplanet. There are planets in the cosmos that resist this fundamental pattern and navigate space independently of stars, contrary to the widespread idea that this should be the case. In this case, we are dealing with rogue planets, which are stars that were either never produced gravitationally connected to a star or were ejected from their original system after they were developed. The heavenly bodies in question are referred to as lonely stars. Instead of forming in the protoplanetary disk, which is the traditional location where stars and brown dwarfs are born, these second sorts of stars, which are referred to as sub-brown dwarfs in specialized literature, have developed as a result of the contraction of a stellar gas cloud. In spite of this, it is a well-known fact that such solitary planets are infamously difficult to locate across the entirety of spatial space. Additionally, they do not shimmer in visible light and barely reflect the light of the stars. Infrared telescopes, on the other hand, can analyze the heat emission of rogue planets or probable candidates in order to locate them. In point of fact, contrary to what one may believe, renegade planets are significantly more prevalent than one might imagine, according to our previous research into our neighbors in the galaxy. In point of fact, an abundance of them may be found in our home galaxy. A majority of scientists are of the opinion that the Milky Way galaxy is home to roughly twice as many rogue planets as it does stars. In addition to the 100 to 300 billion stars that make our galaxy their home, this result indicates that there are around 400 billion planets in our galaxy. It is now common knowledge that the Orion Nebula is home to a disproportionately high number of planets that are considered to be rogue. The discoveries made by Webb regarding the Orion Nebula, astronomically speaking, the Orion Nebula is located in quite near proximity to us. Due to its proximity to Earth, which is only 1,350 light-years away, and its role as one of the galaxy's most active star nurseries, the vast cloud of interstellar gas has acquired a great deal of attention in the most recent decades. According to research, the Orion Nebula contains an estimated 2,800 inactive young stars, and the region surrounding it is replete with a great number of spectacular celestial objects. The near-infrared NIRCam camera on the James Webb Telescope captured 2 wide-angle mosaics of the Orion Nebula a few months ago. These mosaics help shed light on the well-known star nursery in a manner that had never been seen before. A discovery has been made that does not in any way correspond to the astrological scenario. These photographs, which number over 3,000 in total, illustrate this. For example, 40 planets that are free-floating and, as was mentioned earlier, do not have a mother star in a single sweep of the sky. In spite of the fact that there have been earlier discoveries of rogue planets in the Orion Nebula, these particular celestial bodies are exceedingly massive. They are referred to as jumbos, which translate to Jupiter-mass double objects. Jumbos are, to put it gently, as absurd as their name suggests, which is the primary reason why researchers were caught aback by this discovery. In the Orion Nebula, it would appear that these planets that appear to be alone actually occur in pairs. In light of this, what is the background of these unique groups of stars? The James Webb Space Telescope has granted us unprecedented access to understanding the properties of these celestial objects, often referred to as jumbos. Through a swift and meticulous analysis of Webb's imagery, scientists have been able to uncover fundamental characteristics of these young stars, shining new light on the birth and early evolution of massive celestial bodies. According to the findings, these stars appear to be celestial whippersnappers or extremely young stars, with surface temperatures reaching approximately 1,000 degrees Celsius, surprisingly cool for stars of their mass. Additionally, these findings suggest an age of only around 1 million years, an extraordinarily brief span in the context of stellar evolution. This youthful age indicates that these jumbos are still in the initial phases of development, just beginning their long journey toward maturity. Studying these stars helps us understand not only their unique physical properties, but also the broader processes and timelines of star formation within the universe. The answers to the mysteries of the jumbos. The Orion Nebula is known to contain a large population of jumbos, with many existing in pairs. This is a particularly interesting observation because stellar pairs of this kind are relatively uncommon and pose the question, what could have caused this phenomenon in the Orion Nebula? Truthfully, our current understanding of these jumbos is limited, and we can only speculate about their identities and origins based on the data gathered thus far. One possibility is that these jumbos originated in a region of the Orion Nebula where there was insufficient material available to sustain the full development of stars. In this scenario, the molecular cloud from which they emerged may have lacked the necessary density and mass of hydrogen to initiate nuclear fusion, which is required for traditional star formation. This shortage of hydrogen and other key elements for fusion might explain why a sort of column of failed stars seems to exist in this part of the nebula, consisting of jumbos that never achieve true stellar status. Another intriguing theory suggests that these jumbos may have started out in the process of regular growth, forming initially as gas giants similar to Jupiter. During this early phase, the jumbos would have accumulated material and developed much like typical gas giants in other star systems. However, some unknown event or force may have intervened, potentially ejecting them from their original systems and causing them to drift into isolation. This could have happened due to gravitational interactions with nearby massive objects, or even by disruption from the violent stellar winds and radiation common in star-forming regions like the Orion Nebula. There is also a chance that these jumbos were part of binary systems that underwent dramatic changes, such as gravitational interactions with larger stars or supernova explosions, which forced them out of their initial orbits. The possibility of such interactions could explain why many jumbos appear to be found in pairs, as they may be remnants of these disrupted systems that were left behind after being ejected from their original locations. While we continue to observe and collect data on these mysterious objects, each of these hypotheses presents an exciting opportunity to understand more about the unique formation processes within the Orion Nebula. These jumbos provide a valuable window into the diversity of celestial formation and behavior, challenging our traditional views on what constitutes a star, a planet, and the dynamic processes that shape stellar nurseries. We still do not know why the planetary planets were separated from their parent stars in pairs, despite the fact that scientists have asserted that the ejection scenario is the more reasonable explanation. It is possible that a more precise explanation might make it sound different, but when we take into account the constellations that are aligned, is it even somewhat possible that what we are witnessing right now is the result of pure possibility? In the end, the heavenly bodies are bound together in their paired nature because of the similarities in structure and mass that they share with one another for the most part. This leads some academics to propose that we need to accept the reality that current hypotheses regarding the birth and growth of planets are likely badly inadequate. They argue that we need to embrace this reality. In essence, we do not have any idea what the fundamental process is that might be responsible for supporting the structure that is present in the Orion Nebula. It's possible that the building that matches is a full-fledged jumbo factory in addition to being a star producer who puts in a lot of effort. If hydrogen density is constantly distributed in particular regions in such a way that it can never generate an actual star, but always two gas planet-like objects that are gravitationally connected to each other, then it would no longer be called a coincidence, but rather a pattern. This would alter the definition of the phenomenon from a coincidence to a pattern. The official clearance of this technique is still being sought, despite the fact that it appears to be logical. On the other hand, the fact that the James Webb Telescope has picked up a number of objects that had researchers scratching their heads is now officially confirmed. The extending of the boundaries of cosmology by Webb's experiments, the so-called impossible galaxies, are the first and primary of these. These galaxies existed approximately 500 to 700 million years after the Big Bang, and despite this, they had star masses that were as high as 100 billion solar masses. These structures have been given the name universe breakers due to the fact that they contradict the conventional viewpoints of the universe. According to our hypotheses, the rapid production of stars should not have been conceivable because there was not enough normal stuff present during that early time. In typical galaxy formation models, the universe's early moments were defined by a scarcity of the heavier elements needed for rapid star formation. Most of the material present was primordial hydrogen and helium, with only a limited amount of heavier metals that generally facilitates star creation. Conventional theories suggest that during the first few 100 million years after the Big Bang, the universe lacked the necessary density of this normal matter, such as atomic hydrogen, helium, and trace elements, to support the creation of massive stars and galaxies at such a rapid pace. Yet, the discovery of these universe-breaking galaxies indicates that stars within them formed with remarkable speed and volume, accumulating masses far beyond what current models would predict. Adding to this mystery is the fact that these galaxies should have had limited time to accumulate gas and dust for star formation. The typical timeline required for galaxies to grow to such enormous sizes involves many stages of gradual merging and accretion, often spanning billions of years. However, these impossible galaxies seem to have undergone an accelerated formation process, somehow producing and sustaining massive amounts of stars in only a few 100 million years. This finding has confounded astrophysicists, as it contradicts the anticipated pace at which galaxies and stars could grow in the universe's infancy. The implications of these universe breakers are significant. If our theories about early star formation cannot account for such massive structures, it suggests that either some unknown physical processes were at work, or that we need to revise our understanding of how matter and energy interacted shortly after the Big Bang. One possible explanation is that the earliest galaxies had access to vast reservoirs of dark matter that facilitated their rapid growth, though this hypothesis remains speculative. Alternatively, the presence of exotic particles or undiscovered mechanisms could have contributed to this intense burst of star formation. These impossible galaxies may indicate that the early universe was far more dynamic and complex than previously imagined. They suggest that the processes of matter condensation, star formation, and energy dynamics in the infant universe may differ fundamentally from the mechanisms seen in later cosmic history. The existence of these structures invites us to reconsider what we thought we knew about the primordial universe, potentially opening up new pathways for understanding dark matter, dark energy, and the cosmic forces that shape the early cosmos. To the same extent as we did with the jumbos, we need to inquire about the degree to which our theoretical model of the development of the cosmos corresponds to the processes that are actually taking place in the cosmos. The massive black hole that was detected by the James Webb Telescope in a galaxy that was also born in the early stages of the universe is just as mysterious. In spite of the fact that this existed 770 million years after the Big Bang, it had a gravitational monster that was larger than 1 billion sun masses in its center. After conducting an investigation into the mechanism that feeds the black hole, the experts found nothing out of the usual that might possibly explain the black hole's rapid expansion. On the other hand, the background of the item looks to be shockingly mundane, which ultimately leads to an even more significant cosmic mystery. We do not know what caused the universe to go through such a mysterious expansion surge, but the supermassive black hole was fully formed at a measly 5% of its present age. The second issue is the so-called Hubble tension, which is present. Using the Hubble constant as a starting point, one can theoretically determine the pace at which the universe is expanding. One peculiar contradiction, on the other hand, has been discovered in prior research. In spite of the fact that the Hubble constant, which is responsible for accounting for cosmic background radiation, has a theoretical value of 67 kilometers per second per megaparsec, the numbers that researchers found were significantly greater. When red giants, supernovae, and the one-of-a-kind Cepheid star type are taken into consideration, a figure of 73 kilometers per second per megaparsec is abruptly reached instead. Consequently, does this constitute a pattern of systematic measuring mistake that has occurred throughout history? As a result of the discoveries of the James Webb Telescope, the Hubble tension has been confirmed, therefore that is not an option. There is a possibility that the universe is expanding at a faster rate than what is currently accounted for in the cosmological standard model. This might be due to the presence of an unorthodox form of dark energy or dark matter, for example. Additionally, it is possible that there are particles or fields that have never been heard of before, or that our understanding of gravity has been erroneous. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.